Hello everyone, here we are again, Digital Design Part 2. Today I will give some clarifications about the previous video to address some things that confused you from what I saw in the comments. And we will start from where we left off last time. We have Billy Orr, two designs, one circuit, exactly the same, meaning what one can do, the other can do as well. Let's take a look at a couple of things on truth tables, because apparently you didn't understand how a truth table works and what it actually is. In reality, it's a diagram, a map, a digital circuit, who says what will come out at his output in the different situations his input may find. And when he has more than one input, he will output the combination of the situations his input may find. For example, here at the OR gate, the gate is a circuit, the OR gate, where X is its first input that can only take 0 and 1, and the second input is Y, which can also only take 0 and 1. When we say 0 and 1, we mean it is 0 when this wire has no voltage, and 1 when this wire has some voltage, you see? Or there may be switches, sensors, some other digital circuit in front of it. That is, it can take input in both analog and digital form. Only 0 and 1, the digital, will understand this, but the input can be anything. So in this specific term, we put X 0 and Y 0. Outside here, it will give us 0. This is the first state. If we give X 1, no, in X 0 and Y 1, the second state will give us 1 here at the output. And so we continue with the remaining states. And what did we say now? When we see this here, and, when we see and in a function, it will immediately come to mind that there is an OR gate there. So the sum that we see here will be implemented as an OR gate in our circuit. When we see a product in a function, we will design an AND gate. And when we see a highlighted letter, we will design a NOT gate. That's it. That's all. It's as simple as that over here. Another thing I want to mention about the truth table we are constructing is how we will arrange the combinations of input states. For example, if the input is 2, we will start with 0, 0, which in reality is the number 0 in the decimal system. The 0 is not digital. We will then move to 0, 1, which is 1 in decimal. We will go to 0, 0, which is 2 in decimal, and we will finish with 11, which is 3 in the decimal system. The two inputs together make 4 combinations, from 0 to 3 in the decimal system. If we had 3 inputs, our combinations would be 2 to the third, so we would have 8 combinations to bring down, from 0 to 7 in decimal. If we do it in binary, the arithmetic will be doubled accordingly. All right, that's about truth tables. Now let's see the simplification we talked about in the previous video. Why should simplification be done, we said, in order to create the smallest circuit possible, easily and economically. And we said, in order to create a digital circuit, we must have the Boolean function of the circuit. When I start to build a circuit, I don't forget what function, I don't know what will come out. I first create the truth table and then derive the Boolean function and then build my circuit. So let's discuss some ways to go from the truth table to a function. I will start, of course, with the truth table of the OR gate, our familiar gate, which we had also done in the previous video. And we had seen a way to derive the function. Let's remember then the first way, we look where our function in f is equal to 1 in each column. It is here. We see in these positions where f is equal to 1, and now we look horizontally at x and psi in each column separately horizontally. Since there are 3 combinations that give us f equal to 1, we will create 3 triples. So we will put here to create 3 triples with the products of x and psi. meaning I will multiply x and psi horizontally in each column and then add them all together. That's it. The letters, like this, x and psi, not 0 and 1. And there I will add, where x or psi is equal to 0, I will emphasize it. That's it. Let's do it. What do we see in the first? x0, so I emphasize it. So we said where 0 is an accent, x accent on psi, which is 1, I will leave as it is, psi. Let's go to the fourth sum. In the fourth product, rather, x is 1, so I leave it as it is. Psi is 0, so I emphasize it, psi tone, that's right. And let's move on to the third. X is 1, psi is 1, so I leave it as it is. X times psi. This is the first way to create the function, and specifically, what do we observe now with what we have said before? In my function above, it starts x tone times psi. We said wherever we see a tone, we will think of a south gate. Wherever we see a peak, we will think of a north gate. And where we see a sign, a west gate. Here we have all three from the function. I have the combination of all three gates we have learned. And of course, together is the seismology connected to the gates. The function. I showed you in the previous video this specific function, how we made it with gates. How we connected it, that is, to gates above. We will see it below in other circuits, how we can build it. And now, let's move on to the second way we can derive a function from a truth table. Now we will look at where the function f equals 0 vertically, like this. Before we looked at where it equals 1, now we will look at where it equals 0. Only the first row has 0 we see here. X is 0 and y is 0. And what we do now, we will not do products now, and we will sum. We will sum and multiply them together. In a specific case, we have only 1, so there is no need for multiplication. But we will only do one addition, x with psi. And what will we say now? Where x or psi is equal to 1, then we will stress it. Before we did the opposite, now we will do this. Whenever we see 1, we will stress it, and we will add, so we will not multiply. So what do we say in the first? X is 0, so we don't stress it, we put it as it is x. That's right, we do not put an accent, it's also 0, x plus psi with p. And since p is 0, we do not emphasize p. Perfect coprime, also we don't have any other 0 in f. So this is the result, x with psi. And what is this? What we will observe is the truth table we had before the OR function. F equals x with pi. With this method, the function was simplified directly. And of course, sin indicates the gate time like that. Two functions we said are equal. Just one has more components than the other. Simplification can also be done with the other method like this and with the Carnot table. We will do this now. I will not show it to you. Maybe I will do it in some other video. Let's look again at the second way because we didn't have many zeros in f. We will do it at the gate if we don't do it this way. Here you see we have 3 zeros in f, so we will make 3 products like this. Now we will create 3 products with the remains. X and pi. Let's start with x0, pi0. So no accent is needed. We put x plus pus like this. We put it in parentheses all together, and we move on, opening a second parenthesis. The second one x0, so we leave it as it is. P's 1, so we accentuate it. We make it x plus pi with an accent like this. Close parentheses, open another parenthesis with the potentials. x1, so we emphasize it with an x tone. Sum e and psi is 0 where we leave it as it is, and our function is all this. X sum psi times x sum psi tone times sum psi. This is the function of ant in this way. Let me do the other way where f is 1 to see what will come out. We see we have a way only at one point here. So we said where 1 is not emphasized here, and we make a product. X times y is the function in 4 ways. We see that it is the same function as the one we saw of ant, the simplified one. These same ways are called functions with minimum or maximum terms. One way and the other. We said that for simplification we can also use Alder-Weibel or the Carnot table, which we will do in some other video. It's a small table, we put in the 1, simplify it, and another function comes out. The simplest function will come out if we do it correctly. With this table, which is the one I use that suits me better. That's all for today. In the next video, we will create a simple circuit to see how it's done. If you have any questions, you can write to me. I look forward to your comments. And until the next video, have a good time. Hello.